Hello guys, welcome back, and in this video I'm going to explain how to write Verilog code for half adder in data flow model. So I pre-assume that you all know how half adder works and how the inputs and output combinations would be. If not clear, you please watch the previous video, that is half adder using structural model. In that I gave a brief explanation about half adder. Now let me assume that you watched that video, and I will continue with direct writing Verilog code in data flow model. Okay. Now in data flow model, again the inputs and output combinations, how to write these things and all are same. The only change is, instead of using directives, you will use the keyword assign. That means you are assigning the value, the output of this A XOR B to the variable S, and you are assigning the value of output of A and B to C. So that is the only difference that you have to do in the data flow model. That means you are indirectly writing the code for the flow of data, how the data is flowing. That's why the name data flow is given. And one easy way to remember is you will use the keyword assign in data flow model. Now after writing the code, if you want to synthesize this code, then you have to write the test bench, which I have already done. Let me show you how to write the test bench also. And one thing, the test bench won't change for any level, because the input combinations won't vary, right? So they will be same like 0 0 0 1 1 0 1 1. So the test bench explanation is as it is same, irrespective of the level of abstraction that you are writing the code. It might be data flow level or a structural level or behavior level, it doesn't matter, but the test bench would remain same. So the test bench is same that I wrote. $finish is used to get back to this window, and $monitor is used to display those values whenever there is a change in these values that you wrote in the braces, and the possible combinations with some particular delay, 2 into time direct 2 nanoseconds. So for every 2 nanoseconds I wrote different combinations. Register Y registers are given for inputs in the module, and outputs are declared as sum and carry. That means not in test bench, but in the module A and B are inputs and sum and carry are outputs, right? So why you are using reg and where, all those things I explained in the data in the structural model. You please refer that video, but the test bench would remain same. Now let me show you the waveforms, which would be again same for this also. So the waveforms would remain same because yeah, one second, let me show you the waveforms. They are loading. Yeah, here you can see the waveforms. They will remain same. Here you can see with all possible combinations. Okay, 0 0 0 1 1 0 1 1. So that's it. Up to 20 nanoseconds they remain unaltered because I didn't change at the input. So once you are done with this thing, then you can okay, I will close this window. Yeah, now you can also go with RTL schematic. You can view the RTL schematic also. You'll get here, see. Okay, so this is how it would be. This is the inbuilt, as it is inbuilt directive of XOR gate. This is inbuilt directive, 2 inputs, 1 output, and this notation is also 2 input AND gate. This is also a directive. So this is how the schematic would be, and this I didn't explain in the structural model. You please there also check the RTL schematic. It would remain same for structural model also. So that's all for this video. See you in the next one, where I will explain how to write code for half adder in behavioral model. See you in the next one.